Yeah, thank you everybody for coming to this webinar. So this is our ChemMatCARS Restart of Operations webinar, in which hopefully you'll learn everything you need to know to plan for your first experiment or first return experiment at ChemMatCARS. So I'm not going to tell you everything you need to know, but throughout the next few talks, hopefully you'll learn, what everything, the various techniques that will be available, when they'll be available, when you can apply for beam time, and things of that nature. So this is the agenda here. Benoit and I will start with an overview. Provide an overview of ChemMatCARS. She'll provide an overview of user operations. And then the three lead scientists, Yushen Chen, Wei Bu, and Mrinal Bera, will each talk about their particular technical areas: crystallography, liquid interfaces, and ASWACs. And then we'll have a question and answer session, which I hope will be questions of a general nature. More technical questions regarding specific techniques, I think it'll be easier to ask those during the breakout room discussions that will follow, where we'll have a separate breakout room, a Zoom breakout room for each of the three areas. And that would be the best time to get into detailed technical questions. But anyway, I would prefer if you hold your general questions till this Q&A session after these first five, hopefully short talks. Let's see what's going on here. Okay, so this is an overview of the ChemMatCARS team. Not going to spend a lot of time talking about this. The PI, co-PIs are on the left over here. Benoit, who is the executive director, is on the right. Natalie Chen, the user coordinator that users interact with a lot, is also over there. In the middle, we have the teams now. So I think a lot of you are familiar with Yushen Wei and Mrinal as the lead scientists, but we've recently started to develop the next generation of ChemMatCARS scientists: Cheyan, Jinxing, Dan, and Dave. And we have a few other important people over here. So this is just announce our intentions to restart our operations. I think most of you are familiar with ChemMatCARS, but perhaps some of you are not. It's an NSF facility for synchrotron X-ray studies at the Advanced Photon Source. And most of our users are interested in using X-rays to understand atomic and molecular processes in a range of fields like condensed matter chemistry, material science, engineering, and biomembranes. And so the scientists who use ChemMatCARS come from across the country, and we have international users as well, and generally to use our advanced crystallography setups, which focused on single crystals at equilibrium and also far from equilibrium, ASWACS studies, anomalous small wide-angle scattering studies, which allow us to do element-specific measurements of disordered materials like soft matter, macromolecules, nanomaterials, and then studies of liquid interfaces, both scattering and spectroscopy for a wide range of areas, some of which I've indicated there. So we've spent a lot of time over the last couple of years upgrading ChemMatCARS, and we're preparing to restart operations. So some of you have heard more about this than others, but the basic idea is that we've built a second beam line. This is going to double our capacity for doing science and also for other broader impacts. It will increase our beam time for the development of ongoing programs. So we have some programs. I haven't listed all our ongoing programs, but we have some ongoing programs that are quite time intensive. So this will allow them to sort of flower. And we also are developing some pioneering capabilities that I've listed here: small molecule serial crystallography, biomembrane studies, liquid interfacial speciation, and other things. And of course, in addition to doubling our capacity for science, it's going to double our capacity for broader impacts, some of which Benoit will be talking about later. So this is one of the primary motivations for upgrading ChemMatCARS. That is, before the APS upgrade, which is now finished, the beam more or less looked like this. And now, after the APS upgrade, the beam more or less looks like this. And APS is, once again, the brightest synchrotron X-ray source above 3 kilovolts in the US. So this change in beam size or beam shape has a number of advantages for some techniques. It's obviously a smaller source that allows you to have a smaller focus. Our typical focus for all experiments is going to be on the order of a few micrometers. And for specialized experiments, it'll be down to less than a micrometer and possibly even on the order of tens of nanometers as things get developed here. But this kind of source makes small beam experiments much easier. And that'll be important for looking at small crystals, for doing serial crystallography, looking at heterogeneities and interfaces, and just generally in smaller samples. Another continuing advantage of the APS will be that it's a very brilliant high energy source. And this, of course, enhances scattering from barium interfaces. It's very useful for looking at highly absorbing systems, and it's very useful in looking at enhanced diffuse scattering, particularly in crystals, looking at defects, disorder, and dynamics. I will say less about this, but the APS also has enhanced coherent capabilities. And I'm saying less about it because immediately after our restart, we won't be taking great advantage of that, but we do have plans as time goes on to take more advantage of that. So this is a bird's eye view of what our sector will look like. Basically, X-rays coming in from the left here. These two stations in black, that's what we had before. These three red stations are new. We'll have two beam lines, and that will be able to do two experiments concurrently, whereas before we could only do one experiment at a time. So what's being referred to now as 15ID1 is in some sense along the line of the original ChemMatCARS that many of you knew and used in past years. So it uses more or less the same hutches, 15IDC and 15IDD. It has a large range of energy. Will have pretty high flux, not only because of the beam itself, but because we've added multi-layer monochromators, so a brightness on the order of 10 to the 14th. There'll be mirror focusing as we had before, and that's very important to maintain our energy tuning techniques like X-ray spectroscopy and in addition, we'll have kind of a full suite of CRL focusing, which will give us even smaller beams throughout the energy range, both 1D and 2D. So the way we get our second set of experiments going is to kick the beam off, and this is now being referred to as 15ID2. All the optics here, both for 15ID1 and 15ID2, are completely new to help us take advantage of the new APS beam. But in 15ID2, it will feed two new hutches. So what used to be 15IDB has been removed and completely replaced by something new. And 15IDE is now our fourth experimental station, whereas before we only had three. The beam lines have slightly different optical character. I won't go through the details here, but 15ID2 will have exclusively CRL focusing, so we won't have the capability of doing spectroscopy on that beam line, but we will have a different energy range that could be quite useful. So this is going to be a very busy slide. I've just listed a lot of the techniques here. So starting out with the liquid interface studies, 15IDC is our previous instrument that we will continue to use, and all the techniques there for liquid vapor and liquid-liquid interfaces will continue to be available. So current techniques are indicated in black, and new things are indicated in red. And then in addition, we will have a second liquid interface station in 15 IDE, which will have other capabilities that uh, other people will talk about later. I'm not going to go through this in detail. Similarly, for crystallography, we have the 15 IDD station. Uh, um, and again, it's capable of essentially doing everything that it could do before. Plus, we'll have new capabilities in 15 IDB that will be discussed later as well. And then the anomalous SAX-WAX, ACE-WAX, is going to be in the same location in 15 IDD, but it will be largely upgraded. So that's pretty much all I wanted to tell you. I hope that's given you a sense of the expansion that's gone on in the last couple of years, and you'll get a better idea of some of the details of these new capabilities as we go on in this hour. But maybe for now, we should go on to Benoit, who will discuss ChemMatCARS user operations.